just wanted to clarify some things that we talked about in the video, especially when it comes to rationalizing the denominator for finding these 6 trig functions. So first things first, our 6 trig functions, we have our SOHCAHTOA. Let's start with the first 3. So we have sine of theta, we have cosine of theta, and we have our tangent of theta. Now, those are our 3 initial ones. So, SOHCAHTOA. And again, I like to start by labeling my sides. Now, I should have put a right angle here, sorry. But if you guys do take a look, it probably is easiest to name what is across from your right angle. This is our hypotenuse. Next, look at the angle that we are focused on. Whatever is across from that angle, that is our opposite side. Some of us are still having troubling with our labels. And then the remaining side, whatever is right next to it, that is our adjacent side. So our first 3 trig ratios that we have, sine, cosine, and tangent. When we are dealing with our sine, I'm going to write this off to the side. Now, sine is opposite over hypotenuse. We see that up here in our initials. So our opposite side that we have labeled is 7, and our hypotenuse is the square root of 53. Now, as we've been talking about, we do not like when we have a square root in the denominator. So because of that, to get rid of it, we need to rationalize the denominator by multiplying that denominator to both the top and the bottom of our fraction. Now, when we multiply straight across, both the 7 and the square root of 53 end up in the numerator next to each other. And then the square root of 53 times the square root of 53 just is 53. And that would be our final answer for our sine. Our cosine is always going to be our adjacent side. So notice our adjacent side that we have labeled is 2 over the hypotenuse, and our hypotenuse is the square root of 53. So again, oh, that's kind of ugly. Again, we are stuck with a square root in the denominator, and we do not like that, so we need to get rid of it. So we're going to do the same process by multiplying that to both the top and the bottom. Multiplying those straight across, we have 2 square root 53. And then when you multiply something by itself under the same square root, you have no more square root, and it just is that number. And then last but not least, we have our tangent, which is always going to be opposite over adjacent. So this is a little nice because if we look at both our opposite side and our adjacent side, notice neither of them have square roots, so that's good. So 7 over 2. Now, our 3 new trig ratios are these reciprocals. So the reciprocal of sine is cosecant. We were told that we need to flip our fraction, and it works best if you go back to your initial, which if you guys notice, our initial problem that we had is this over here, our 7 over the square root of 53. Our life will be made a whole lot easier if when we are writing the reciprocal, all we do is flip that fraction. So we would end up with the square root of 53 over 7. That's a lot less work for us. Because notice, if we went to our 7 square root 53 over 53, and we flipped that, so just to show you guys, we don't have to do this, but this is what it would look like. If we flipped this fraction, we would end up with 53 over 7 square root 53. And then life becomes a little bit more complicated. With this square root in the bottom, we would have to then multiply the square root of 53 to both the top and the bottom. And then you end up with some crazy numbers. You end up with 53. Ooh, again, that's kind of ugly, sorry. 53 square root 53 all over 7 times 53, because remember, the square root of 53 times the square root of 53 is just that number. So then technically this isn't terribly bad. You can cancel those out and you would still be left with the square root of 53 over 7. But notice how it was so much easier when we just went to this initial problem over here before we rationalized the denominator and we just flipped that. We just wrote the reciprocal of that initial problem. So looking at our second reciprocal trig function, for cosine, our reciprocal is secant. And again, we want to go back and we actually want to focus on our initial cosine function, our cosine ratio over here. Because again, this isn't rationalized yet. We can just write the reciprocal of that to make our life a whole lot easier, to be the square root of 53 over 2. And then hopefully our reciprocal for tangent is the easiest here just because we don't have any square roots that we're dealing with, no radicals. So when we just flip that fraction and write its reciprocal, it is just 2 over 7. I hope that kind of helps with the explanation a little bit of what we mean by flip what you initially had. If you have any further questions, please do not hesitate to ask.